everybody, my name's Ian Anderson. I'm the trial ground supervisor here at the STRI. It's my job obviously to manage all the trial maintenance here on the trials ground. What we've got today obviously with me is Simon Gumbrell and Richie Campey. What we're looking at is the actual Imant Sandcat trial. The work we're doing it for is obviously for Campey Turf Care. What I'm going to do to start with is just talk about the objectives that is set out for the trial for the STRI. I'm basically looking at, start with the actual water movement through the putting surface, the moisture retention in the ground, also the surface hardness, and then when we're coming down to the lines that are made by using the Sandcat, we're looking at how quickly we can take out any bobbling effect, so it's back to the untreated sort of ground. And then the final one is basically how long it takes to full recovery, so it's basically like this, there's no sign of anything that you can see. So I'm going to start with is I'm going to tell you a little bit more about the area. This is just a general golf green managed area. The grass is a mixture of annual meadowgrass and brown top bent, so it's like quite a lot of golf greens around the country. The soil underneath, soil profile, is just a general trial ground soil, and that is basically a sandy loam soil. What is important to add to that is underneath this area there is no drainage whatsoever. It is basically the topsoil and subsoil and it's only natural drainage that is going to benefit this area. So I'm just going to work on tell you a little bit about the actual trial itself. There is actually 4 trial plots to the area. There is 2 actual treated plots with the Sandcat, and then there's 2 that are untreated. And the only thing that we've sort of added to that actual treatment is actually a Vision Pro or a transition application, basically directly after we've done the treatments. So we've got 1 on the untreated and 1 on the actual treated plots. And also what we've got is we actually have mirrored everything we've done. So the only thing that's actually really different that we do is the Sandcat treatment. So before we actually do Sandcat treatment, we hollow tine. So after that we will top dress, and we're doing it on both and then rolling, and as we go through, and then the maintenance after, if we do any verticutting and so on, we do exactly the same amount. So it's not altering anything between the 2. They are exactly the same except for the actual treatment that we're assessing against. What I want to do, just as a good sort of start, is if you can just all come and have a look and see if you can work out for me which of the 2 are the treated plots, because it's very obviously important. So like I say, there's 4 plots altogether. There's 2 untreated and 2 treated plots. If you can work out if there actually is any difference, if you can work out which plots they are. It isn't easy. You can tell. There is a slight difference in actual firmness as well, but you find it more if you're like me and you've got quite thin shoes. Is there anyone? No one? That's fine, that's brilliant, that's what I want anyway. So what I'm going to do is I'm going to just tell you which they are. So the 2 treated plots are actually these 2 plots this side. We've treated these 2 are untreated. But as you can tell, the heel up effect is as good as you're ever going to want, because you can't actually tell the difference. There's minute differences, but you've really got to look, and it helps if you actually know where it is as well. That's the thing that benefits you. If you know it's there, you can see it more. That was 15th of June that we did that treatment. We're planning on basically doing per year. This is a 2-year trial, so we're doing 2 treatments per year. So we're planning to do it in spring and in autumn time. The first one we did was a little bit late, to be honest, just because the trial came in a little bit later, so we actually did it a little bit later on. But next year we'll be doing it the 2 times really we're doing. We're doing another one which basically is going to be the next 2 weeks. We would be doing it already, but we want to see what it's like from the heel up, so we haven't actually done that yet. So that's basically the plan with the actual area. So next one I'm going to move on is actually the measurements, and looking at what we do through the STRI, how we look at the measurements to read actually the treatment effects from doing it. So to start with, one of the assessments we do is the actual line assessment. So this is just basically a visual assessment. It's just a scoring assessment from 1 to 10. So 1 being the actual treatment when it's first done, and then 10 being this, exactly as this is now, so it's fully healed up. And then basically like a 5 mark, benchmark 5 is where there's lines, you can actually see the lines, but there's no sign whatsoever of this actual top dressing that are signs. So it's getting there, healing up, but they still can see the lines. So that's sort of your line assessment. The next one I'm going to do is the smoothness and trueness of the actual area afterwards, after the treatment. And that basically, to do that, we have to use this piece of equipment, which is the STRI trueness meter. And what we will do is we'll run this 90 degrees over the actual the lines that were created by Sandcat, give it to worst case scenario, so we're going 90 degrees across it. And also what we're doing is, with all these pieces of equipment, except for the infiltration rings, we're doing 15 actual assessments per plot. So there's 30 on the untreated and 30 altogether on the treated plots. And then when we've done that, we'll do an intensive 8 weeks of actual testing with this equipment. So we do 8 weeks on the trot, and then after that, the next we do basically move down to just 3 items, which we're doing every month, because the other ones have achieved what we basically want them to do. So like I say, I'll move on to this piece of equipment, which is the STRI trueness meter, and just show you actually how it works. So basically, it's easy, right? Turn it over. Basically, it's running probe underneath, and that will allow you to go vertically and horizontally, moving up and down. And it's basically the same footprint as a golf ball. It'll do the same downward footprint as a golf ball, so it runs across the ground. And set it up. And how this measures, basically, if you measure it over, like we'll do it over the set area running across, this will measure in millimetres per metre. It actually does. Just turn it on. Nah, I'll do it, yeah. Yeah, fine, I'll do it. So about just sort of basically walk along, and the speed that you're walking at, setting is done by the lights at the back, so you're trying to get it green. If you're walking green, then you're at the right speed that you're running along at. So that's basically how we do it. We do it over a set distance. Obviously we measure this out and we'll know a set distance we've travelled. Like I said, it gives you a reading at the end of how much it has moved vertically and horizontally over that distance. So that is doing, vertically is moving 31 millimetres over that distance. That's how much vertical movement you have. And then horizontally you have 19 millimetres. So it's doing 19 millimetres over that distance. So that's basically the smoothness meter, and how we're assessing the actual smoothness of the ground. Next piece of equipment we've got is this measurement for the actual surface hardness. And to do that we use this piece of equipment, which is the Clegg hammer. And this basically measures the magnitude in gravity, is how quickly it hits when it hits the ground, in magnitude, how it goes out of the ground. So basically what we've got is a ½ kilogram weight, bottom is shaped same as the golf ball, so it's basically showing as if we're pitching pitch marks when you hit the ground, into the ground. So basically you're dropping it from ½ metre height. From this line you have a set height, and then you get your measurement. It's just a matter of dropping it. Try another one. That was 78. I don't think I did it quite right. Yeah, so at 93, that's the actual reading we're getting, 93 magnitude. So what I'm going to do next is just sort of explain the actual hardness, sort of the reading, so you get more idea. On this kind of area, I would expect it to be between about 80 up to 100. That's what I'm kind of expecting. If you're looking more at the high end of a golf green, with obviously a lower fat content, and that the high end is about 130 around. So you're up from hundreds up to 130, so that's how much you're raising up. And then we'll give it a next move on. If you sort of like contrast, we're looking at a different sport, you're looking at tennis, like taking in context of Wimbledon, they would start at around 200, and they'd be moving up between the tournament up to around 200 to 250. So we're getting obviously a lot harder with the sport. And then finally we go into the real high end, which is cricket, and you're talking up to the 300s, where it's really obviously been rolled a lot, and you're talking 300s up. So we are getting a lot harder through the sports and how to do it. So that's basically how we're using this equipment and how we get the measurement of the actual hardness of the ground. The next piece of equipment that we use is this piece of equipment, which is the penetrometer, and it basically is a 1 kilogram weight with a 1 centimetre probe, and what we're doing is basically it hammers the probe into the ground, and then we measure it in millimetres. It gives us a measurement, and we'll just drop it and it hammers it in the ground, and it gives us a measurement in millimetres, which is 2.8. So that's the first reading. Like I say, we do 15 replicas of each one, but with this actual instrument we actually do 4 drops on the same spot. So we'll do 4 drops and take a measurement of each drop, and that one's got to 4.8 millimetres. And this will allow us to know the hardness of the actual soil through the profile. And obviously with the sand cap machine, it's going in 6 inches into the ground, so it allows us to see how it's affecting it actually further down as well as the actual surface. The surface, obviously we get a difference, and it gets harder because it's obviously injecting sand into the ground, so it's tightening it all up again, so it goes firmer anyway because of the actually injecting it. So it just actually firms the surface up anyway. So the next piece of equipment we've got is for the moisture test. This is a FETA probe, and this will assess the volumetric water content in the ground. It's basically a matter, let's turn it on, matter of inserting in the ground, so it's down, and then taking a reading, and that's at 34.6% volumetric water scale. I'll give you kind of an idea basically of the scales we're running through. Your sort of ideal amount you're looking at is around 25%. That's sort of an ideal amount. So we are getting obviously a little bit higher, it's getting more moist. We are on the untreated as well, so it's obviously, you expect it is all in water more. If you're talking like 50%, then you're talking sort of saturation mark. So there's not air left really, you're just full of water and soil, that's all you really got. And then obviously as you get lower end, getting down 20s and then going down, then you're getting a lot more dried out, and then you get your problems with your, obviously grass showing signs of drought. So that's basically how that scale works, and the percentages of the actual unit. And then finally, the last piece of equipment that we use is the infiltration rings. And how these work is we set them up exactly as they are, and then we're basically using the hammer, we'll hammer them into the ground about 1 inch into the ground, and we'll fill these full of water, and then we'll let them settle for about half an hour. So they actually basically are pushing all the air that's underneath out. It's settling out basically, because there's no point doing this. You have all that space underneath because and you just do it. It's going to give you basically a false reading. It's got a lot more place to go. So we actually give it a sort of a benchmark to start with that we set from. So we'll then fill them up and back top to a measurement, and then we'll measure it over an hour how many millimetres it has dropped over that time. Also what we do at the same time is we measure the actual temperature of the water, because the actual temperature can affect the actual rate that it goes through the ground, because obviously the more colder it is, it's actually more solid is the actual water, so it will take longer to go through, whereas it's warmed up a lot hotter, it will percolate through the ground quicker because it has a lot more thinner it will go through. So that does make an effect. So we take that into as consideration and add that to as averages of stuff, so we know the difference. So the next bit I want to do is basically just run through the results, which are the really sort of important thing. Like I say, we've only done one treatment, which is really important. This is just all the results off one treatment. So what I'm going to do is start with is the actual penetrometer and the penetration through the ground. For this, like I say, we're doing it over an 8-week period. So they're actually showing 3 out of the 8 weeks that we've done it. It's showing with the penetrometer that we're 26% harder on the surface of the untreated, on the treated plots compared to the untreated plots. So the thing as well is it's just going by the first drop. We did 4, but we're just going by the first drop, so it's right on the surface. So that's obviously showing a sign that the actual treatments are working. It's draining away and it's making it harder on top because it's drier on top on the surface and making it all harder. So that's the first one we've got. The next one we've got is the actual hardness of the ground using the clay hammer. To be honest, at the moment we haven't got any significant difference between the two, but we also have taken into context that we did do this in the summer and it's the driest time, so you kind of expect more that anyway. The benefits we're really expecting with this machine is going to be winter time, and we're expecting differences more then because you're going to get the infiltration better and then you get a firmer surface. So we haven't actually found anything yet. The line recovery, which is using basically the Vision Pro transition, to be honest, we found no visual difference at all. It basically didn't change the area at all. It didn't benefit at all. It didn't increase the line's recovery at all. The only benefit you do get, or we've got from it, is the visual one. It does look more healed up just because it is green and you can't see the actual lines as much, and that's the only real benefit that we did get. Moving on to the actual water content of the ground using the Veta probe. On this one, like saying it weekly over 8 weeks, 5 out of the 8 showed that we had a lower moisture content in the treated plots. So that worked out, is that saying that's in units up to 50, that was a 3.2% in units lower, which is about a 63% difference, which is a significant difference between the two, and it knows it's highly significant for it. And then finally, the final result, which is basically the real point of this actual machine, and it's the real high point of the test, is using infiltration rings. We found on the treated plots there was over the hour in millimetres went down 39 millimetres per hour, but on the untreated went down 18 millimetres per hour, and that works out at a 54% difference in infiltration over an hour, and that's just with one treatment. So to be honest, the benefits of that are massive. That is what we class as a highly significant difference between the two. So they were basically showing the machine is doing exactly what you want to do. In some cases, like Simon, more than you could ever want it to do, really. So it's working out. So that's basically as readings. The final thing really is what we're doing next. Like I say, we're planning on doing another treatment this year, and then we'll carry on exactly the same again, springtime and autumn, doing the same again on the 2 areas, carrying on the assessments exactly the same 8-week periods, doing them, and just getting the results really. And as we go along, I think we've sort of realised we can do a lot more to actually benefit after we've done a treatment. We've done the lowest thing you can do. We can do a lot more. So if you set the lowest marker, everything you do on top better is only going to improve it. So we've always set it at lowest. If we set it higher and it's not worked, you've nowhere to go, it's not going to work. So we've set it at lowest marker and you can improve it from there with whatever treatments you do. So that's what we're basically left. So from there really, all I can do is pass you on to Simon. He can run through the actual machine and be working.
Just say one thing to the guys who are probably not aware, that part of our agronomy programme now incorporates all of these tools. So fundamentally with Golf, with the trueness meter and the feeder probe and the Clegg, but also coming in with the French penetrometer, we can also do moisture water penetration, but also through bowls and cricket and football. So we're starting to use the tools to really start to move things forward numerically, so we can see how well we're improving and where we need to get to. And particularly something like the trueness meter, which is a unique product developed by STRI, starting to show some actually fascinating. You can pick up very, very minor details of quality of cut, verticut lines, all sorts of things. So it's a very useful tool in the field, as well as a research tool. And most of the golf courses we now visit are incorporating this kind of program measurement.
Just the second treatment, at what angle would you go compared to?
Well, we're planning about 10 to 15 degree angle difference. That's what we're planning on. To be honest, it's healed up that well. I wouldn't be amazed if you couldn't do 90 degrees to it, because it's healed up that well.
Depends on my driving.
Yeah.
But do you want to come over this way and then I'll explain the practicality of the machine. Right, my name's Simon Gumbrill. I'm from Campey Turf Care, based near Macclesfield in England. As a company, we generally just take machinery out there and do the demonstrations with golf courses and prove that they work. On this occasion with the Sandcat, we decided that we wanted a little bit more technical data, a bit more official proof that the process is working. So we contacted the STRI, who are doing this research with us. We need the practicality, we need them to show data to explain what we're doing. We know that the way we're working with the Sandcat works, but sometimes we just need that data. So thanks to Ian and the STRI, we're going to have printed data for that. Tuesday we came over here and Ian gave us, Richard and myself, the data for the filtration rates at 54% improvement. We couldn't believe that. I mean, that was a dream to us. If we'd have been offered 20%, we'd have snatched at it. It would have been fantastic. But the trials have been going on since June, as Ian explained. So behind you was done in June. The area that you're standing on here, most of you are standing on, was done last Monday. So that is the growing point that you've got within 10 days. And that's had no other treatment with the exception of the Sandcat being pulled through, matted out, and then just tracked in with the tyres of the tractor. That's all that we've done to that. If it was done on your own golf course, you would have done a lot of agronomical beneficial treatments to that. You'd probably have top dressed it again, you'd have seeded it again, you'd have probably rolled it, ironed it out with a True Turf roller or similar. So it would be looking even better than that. This run here we did yesterday morning, so the same as what we're doing today. We put the machine through. We're just doing in 2 metre sections as we go through by each group, so that's why my lines aren't straight, honest. How it works, you've got a series of digging blades at the front of the machine. It's basically an immense shockwave, but with a sand application unit behind it. We have to use kiln dried sand because it's got to flow like sugar. We need gravity feed. It's got to be gravity fed. So the forward speed of the product of the Sandcat, we go forward slowly, enabling the trenches to fill up behind as we go. We've got 6-inch centres, so 6-inch 150mm centres for the blades, and then we're working 150mm deep at the same time, and then with an 8mm blade. So we're filling an 8mm channel, which you see. This is the profile that we've cut out. That is what it will look down throughout the green. On an average size green, 450 metres, 500 square metre green, you would use about 4 tonnes of kiln dried sand. So you're getting that kiln dried sand into the profile. So it could take you a hell of a long time to keep top dressing to get to that, but we're actually putting it through the profile to encourage the drainage. So if you've got water issues or surface stability issues, this will help with that. We'll certainly aid that. Right, I'll give the unit a run, and you can actually see it working. So. Now you spot the deliberate mistake. If you don't turn the sand on, the sand doesn't come out. So, but that shows you how it would work if the sand wasn't there, sir. And ladies, sorry. Yeah, on an average size green, 450 to 500 metre square green, would use about 4 tonnes of kiln dried sand. So you're getting a lot of sand into the profile. And it'd take us about an hour and 20 minutes to do that size of green, depending on how efficient we are at reloading. Because if we fill that hopper, we'd start there, it would just be about running out when we get to the end there.
How much is that holding?
It's 550 litres, but depending on, it equates to about 3/4 of a tonne of material when it's in there. So the horsepower requirement of the tractor, we need very little horsepower, but we need physical lifting ability. So that tractor there is 50 horsepower, because we need that sort of size of tractor just to lift it off the ground. When we actually do the operation, we would pull the machine through as you've just seen there. We would then use a rubber drag mat to level it off. We don't use brushes because you end up pulling the sand out of the channels as you go. So we'd level it off all true and true. We'd seed it, we'd roll it, just to iron it and smooth it up. And then we'd probably needle tine it as well, just to tighten everything up and get additional dressings into the surface. Then we'd put the flag back in and play. So within the day you'd be back in play, and you would have improved the surface. So, and that's basically the sand cap. We have other methods. We use the Air 2 G2 for aeration. We'll use the VGR machine for aeration. So less disruptive methods of aeration. Every golf course demands different things. If you don't have a drainage issue, you will possibly need aeration tools on a regular basis. The members of golf courses, the owners of golf courses, are getting more critical of disruption, so the greenkeepers are under additional pressure. So we keep coming up with new products to enable you to do your job better, to get the growth so that you can play through the winter months. Because the UK is quite unusual in the fact that we don't have a closed period for golf. We just have to play through. If they want to play on Christmas Day, they will be playing on Christmas Day. So that's what Campey Turf Care try and do. In conjunction with the STRI, we'll try and keep that going. That's me about done. Thank you very much. Thank you. Thank you.